Good morning, happy holiday, happy time zone, whatever the standard greeting is for wherever you live. It's me again. I'm back to work on my game engine. I was live for a couple of hours yesterday, and I decided to just terminate it. And I don't think I'll be publishing that stream because it was basically just wrestling with build system stuff for a long time. But what I'm working on is text rendering on my game engine. Presently, I've got a very basic 2D renderer where I can render, I can batch render 2D sprites. I am attempting to integrate the MSDF Atlas Gen library from GitHub. This is just a really cool library that takes and will tightly pack a texture atlas with high quality multi-sign distance field atlases. So the idea behind this style of a texture atlas or a font atlas is to, sorry, I'm pouring my coffee and trying to talk at the same time, is to allow you to do really crisp, clean glyphs that are independent of resolution. So like to show the demonstration from the single character version of this library, you've got a demonstration of multi-sign distance fields on this side, or sign distance fields on these sides. So these two images in the pixelated blurry letter A, those are they're on different lines. This and this are sign distance field glyphs stored 16 by 16 and 32 by 32, where basically every pixel in the image is the distance to the nearest edge of the letter. So you can take, when you go to apply linear bifiltering on this texture and it gets all blurry, not unlike you can see here with the Hollow Knight sprite, where it's like you can still kind of tell where the pixels in the texture are, but they're blurring together linearly. Where was I? You can determine whether it would be in the high resolution glyph's edge by comparing the distance from the center of the pixel to where it would be on the glyph. So after you're above a certain threshold, then you're in the glyph. Otherwise, you're outside of it. But it leaves these little artifacts on the corners where it gives you rounded corners instead of sharp, clean corners, because the distance to the nearest edge at this point might be it might be either edge. So basically, this guy came up with a really creative solution, which is to store like adjacent edges using different color channels, so that when you are sampling the edge, you just do a little bit of extra math in the shader, and you can sample the nearest edge that's appropriate for the edge that you're looking at. So like the on each corner, you have different color channels handling each edge leading up to that corner, and that leaves you with nice, clean, sharp glyphs. Now, the trouble that I'm running into now, I've got the library in there and built, and I'm testing it. I've technically got it running now to build a texture atlas. I've got MSDF Atlas Gen as a project, and its sub-project MSDF Gen, and its sub-project FreeType. So I've got all those dependencies building. But the problem is that the while MSDF Gen has an excellent guide for using the API, using the library API, there's no guide at all for using the Atlas field Atlas generator. So for the most part right now, I'm just kind of having to hack it together a little bit, trying to figure this out, and that's what I'm going to be spending this morning doing. Should probably pull up chat in case somebody comes in. There we go. Anyway, so in order to kind of figure out the library, I am using the standalone console application that comes with it. I am reading through its source code to kind of learn how it does the generation, and I've gotten pretty far. So for starters, what they do is the API doesn't handle the actual loading of each glyph from a font file. You still have to do that manually through the MSDF Gen API. And I've gotten that far. So in fontatlas.cpp, this is the place where I'm eventually going to have the API to take a path to a true type font file, have it automatically generate the atlas, then send it to the graphics card for use in texture sampling, and then return to the game engine with a texture handle and bundled up in some way the UVs for sampling all the characters and kerning and things like that. But for now, I'm just making sure that I've got an understanding of the API. So what I've done is I have loaded up the boldface Arial bold from my computer's Windows Fonts folder using the MSDF Gen API, which is actually exactly how MSDF Atlas does it. And then I go through and confirm that everything actually loads by using the checking code from the console application. So when I go to run, I have to comment that stuff out again. When I go to run, I can confirm here that loaded geometry of 95 out of 95 glyphs. So far I've got the, in memory, I was able to load the vector geometry of each glyph in a format that MSDF Atlas Gen can use. I'm pretty sure that's right. But I'm running into a bit of confusion around getting the Atlas packed. There's this helper class, Tight Atlas Packer, which appears to be a helper method or helper class that you feed it your constraints and your requirements for the atlas, and then it will generate the numbers that you need to plug into your algorithm for actually generating the atlas. And that doesn't seem to be working as I expected. So I've set, in this case, I set a dimensions constraint. Instead of actually saying I want the texture atlas to be this big or this big, I set a constraint to say it needs to be a power of 2 square. I set a minimum scale for the characters to this value default EM size, which is actually a constant within the MSDF Gen library, I believe itself, right? MSDF Atlas, yeah. Located in MSDF Atlas font library glyph range. So that's a default value of 32 means that it's going to be 32 point size font, I believe is what that means by default, is the sample. And EM size is like the dot size, the dot resolution of like a web image. I'm a little vague on the details, but EM is something that's like supposed to be independent of pixel resolution. Set padding to 0, which is actually the default, meaning that you don't have extra space in between the the in between the glyphs on the atlas. Set pixel range. I'm using default values that I actually just pulled out of the console application. So these are not my values. These are values from the console app. So the default pixel range means, or the set pixel range means how many pixels distance to the edge do you want to encode, and so this default is 2. So meaning that you got from the edge, you got 2 pixels out, describing the range towards the edge, which should be enough. Because if you take a look at, like, if I do 16 by 16, 2 pixels is actually a considerable distance away from the edge. And then the default miter limit is 0. I'm pretty sure. Mitering is or it's 1. Mitering meaning, like, if you wanted to use the glyphs to do special effects, like mitered text, like, pull up a quick sample of it. I'm only getting it working. Style. Mitering is where you do the on the edge of the character you have a beveling effect. Like I don't know, this is maybe not, if you can imagine it, having like an extended edge, which is a little different than just boldface. Or like in the Mario, like a Mario Kart logo. Like the border going around the edge might be done by a mitering effect, because it's like a fixed width from the edge of the character. In this case, it's clearly not, because it's just a 3D logo. But mitering is basically you can take the sign distance field and increase the threshold. So like the threshold up until like 0.5 for an alpha value would represent the edge of the character. Then you could say, like, okay, but also from 0.25 to 0.5, make that be like the solid colored black, and we'll give it a mitered edge. The default value for that is 1, so I'm just sticking with it. And I think I've set everything that is set by default in the console app. But what I'm finding is that when I go to run and print out the data that I get from the Tide Atlas Packer, I'm getting dimensions of -1 and -1, which is an erroneous value, and I'm getting a glyph scale of -1. So this tells me that the Texture Atlas Packer is giving me a empty texture. If it was to try and make a texture atlas of the dimensions that I picked, or out of the constraints that I picked, which confuses me, because I'm pretty sure this is just the default case that's provided in the app. So I'm going to spend the next little while peering through that code and seeing if I missed setting something up or whatever. Interestingly, though, it does say remaining glyphs 0, so it actually did. So either it did consume all of the glyphs that I fed it, or it just says 0 when it gives up on setting up the dimensions. Well, you know what, though? I just had a better idea. Instead of going through all the code that I just went through to get this far, I'm just going to go ahead and step through the library code, because I'm building the library myself as a dependency. I can actually just step through the code. So let's go to line 81, press F1 again. All right, so at this point we've got the texture atlas packer, I've given it a null width and null height. I said get dimensions based off of the constraints that I set, and it's supposed to update the width and the height, but it hasn't done that. Oh, okay, hang on. I think something clicked in my head. It occurred to me that I might need to be packing before I do anything else. Because I didn't send it. Oh, I'm an idiot. It might have been working the whole time. Let's see. Because until you call packer.pack, maybe it doesn't have all the glyph information. And of course it wouldn't. So how would it know what height or width it needs to be? Okay, we'll see how this goes. Hopefully I'll get better results this time. I last left off on this at 11 o'clock last night. I wasn't coding at my best when you always want to get your sleep because you stop being effective. All right, let's take a look. Oh, that is perfect. Okay, cool. So I think we're ready to move on to the next step then. So taking a look at the dimensions that the tight atlas packer created using my default stuff, I told it to make a power of 2 size square texture for the purposes of effective use in OpenGL. I suppose I could just say power of 2 rectangle texture would work fine, but I don't know. I just kind of have a preference for squares, even though technically it'll do mipping at power of 2 quite well. I'm not aware of a graphics constraint why I would have to use power of 2 rectangle versus power of 2 square. So it's giving me a 256 by 256 texture for 95 glyphs. Pixel range 2.0, glyph scale 36.3125. That would be the EM size, so that's the resolution independent pixel size for fonts used on the web. Remaining glyph 0, meaning that it successfully packed them all. So let's see if that checks out. Let's do it back in the envelope. Double check. So if we're talking about 36 by 36 pixels, a little over, but I'll undershoot it for the moment. 36 by 36 pixels, we got 1296 pixels per glyph, or EM pixels, or EM, whatever they're called. I think they're just called dots in the font world. And then we've got 95 glyphs. Divide that by 256, we get 480, which is, more than the other dimension 256. So this might not be very tightly packed. Like there might be a bunch of room left over. So I may want to drop my constraint that I am packing into a power of 2 square. Maybe I can do power of 2 rectangle. That's the other one. And maybe what that'll do, and maybe that's why it offers power of 2 rectangle, is because if you're forcing it into a square, maybe it leaves you with a bunch of unused space. Interestingly, it still gives me 256 by 256 when I do that. Even though I said use a rectangle if you want this time. So I don't know, maybe there's something else going on, or maybe I'm misunderstanding the concept of EM size. But I'm gonna put that on the back burner for now, because it looks like I've got the data I need. The width and height, and the pixel range, glyph, and all that stuff, to feed into the next step. So let's figure out how that works. So coming back to the console app provided with the library. I'm heading down to the part where I left off. Determine final atlas dimensions, scale and range, pack glyphs. So this is where we were. So I followed this as a guide to come up with my use of the Tight Atlas Packer. Thankfully, the Tight Atlas Packer is pretty well documented. Like the API stuff seems to be like they have comments that kind of explain things pretty well on the classes that you need to use, but it's sort of hard to distinguish them from the things that you're not supposed to use. And there's no full manual on how to use it. So at this point, what has happened is they created a Tight Atlas Packer. They set it with very conditional code. They set it with the details that are important depending on what you entered into the console app. So basically, every option is on the table. So there's a whole bunch of if, else, and whatever going on in here. I just did mine with the default settings and learned what settings I'm allowed to plug in. And then at this point, we've got config.emsize equals atlaspacker.getScale. Config.pxRange is getPixelRange, and then there's only one other getter, and that's dimensions. So config.width and height. So config is a little helper struct that the console app uses to hold on to this information. And to be honest, I'm not really a fan of how this console app is coded, because there's a whole bunch of like C++ things in here that don't have to be C++ things. Like they could you don't have to create a class config to store one configuration that the application will use from start to finish. Like that's, yeah, and like this is all within the console app, not part of the API. This is part of main.cvp, so you don't get it from the headers, which is like, yeah, whatever. But setting that aside for a moment, it looks like the important part of using Tight Atlas Packer in that situation was to get those values into config.emRange, pxRange, and width and height. So here's where they actually do the bitmap, which they totally skip if you are doing just a layout. So layout only, let's see how that's defined. It's defined by whether it's true if the user has not specified a font file name or an image file name. Artery font file name is actually not the same thing. So an artery font file name, Artery is a game engine made by the person who made this library. So there's some tight integration there that we're not even going to use. So artery font refers to like a bundle of data that this can produce that's used for the Artery game engine. So if you don't specify a image file name to output the stuff to, or a font, an Artery font file to output the stuff to, then we say it's layout only, and we only generate the layout information. So that would be the stuff that goes into the CSV file or the JSON file describing the texture atlas. So taking a look here, edge coloring, config, image type, MSDF, and MTSDF. These are the two kinds of images I care about. The library can produce regular distance fields as well. So taking a look at the atlas types, MSDF and MTSDF are here. MSDF being the multi-channel signed distance field, which is the thing I most care about, which gives you the super crisp, clean glyphs when you go to sample them with a specific shader algorithm. MTSDF is that plus a regular signed distance field plugged in the alpha channel, and that's important because there are some effects where you want the distance field to be rounded on the corners. So if you were wanting to do a glow effect, for example, on the text glyph, then you could use the multi-sign distance field to do that, but it would give you a uniform edge, kind of like a mitered edge. So it might still look like a glow, But if you want your glow to look more like you've got like an LED behind it, for example, then to make that a little bit more natural, you would want the, in addition to the multi-channel, you'd want the regular one. So I pretty much will only be using these two. Maybe only this one, because given the nature of my library, I don't know whether a developer will know in advance whether they want to use one versus the other, and it doesn't really affect how they would program their shaders. In truth, so like you can use the same algorithm to sample an MSDF as you would for an MTSDF. You're just not sampling the alpha channel. But yeah, these guys I don't think I care about. Hopping back to the code. So if it's MSDF or MTSDF, we do this stuff. Otherwise, well, actually, I guess that's just prep work, because there's something going on here. Make Atlas is being done on MSDF and MTSDF anyway. And then after that's done, I guess that's it. So basically the generation boils down to make Atlas. But what's the prep work that we're doing here? Config.expensive coloring. So this hinges upon another user setting, expensive coloring, which let's find out what it does. Expensive coloring is set based on coloring strategy, the parameters sent to the console app. Even though the library that I'm using doesn't have documentation, the console app that uses that library does. So I can actually take and look up the human readable description of each of the console commands, console arguments that will trigger a setting I'm interested in. So this is set by using coloring strategy, symbol, ink trap, or distance. Selects the edge coloring heuristic. By this, I'm presuming it means determining which color to use on which edge. Which is interesting. I don't actually see a description of that. So let's go to the MSDF gen library. I was searching to see if I could find heuristic in here, but maybe not. I need to figure out how it's used. Let's search for distance, or let's search for ink trap. It's a pretty distinctive word. No, simple. Okay, here we go. So when you're doing just the letters by themselves, you normalize the shape using its normalize method and assign colors to edges if you need a multi-channel SDF. This can be performed automatically using the edge coloring simple heuristic, or manually by setting each edge's color member. Keep in mind that at least 2 color channels must be turned on in each edge, and if 2 edges meet at a sharp corner, they must have only 1 channel in common. Okay, so I guess the simple is the default. It's the automatic setting. I'm supposing that this option coloring strategy is only there for completeness sake. Though let's keep reading in the code. Maybe the ink trap configuration will clarify things. So there's 2 parameters set by this. There's the actual coloring mode, and then there's expensive coloring, which is false except for in the case of coloring by distance. Oh, okay. There's helpful comments on these. Let's take a look. Oh, that's interesting. Oh, these aren't. These are method calls. These are not just members. They are pointers to functions. So when I go to control click on it to get the definition, it actually gives me the algorithm used. Let's read through these descriptions. Edge coloring simple, assigns colors to edges of the shape in accordance to the multi-channel distance field technique. May split some edges if necessary. Angle threshold specifies the maximum angle in radians to be considered a corner. For example, 3 or about 170. So I'm assuming that means 3 radians. Is that right? Three radians? Yeah, because 3.14 is a half circle. So 3 radians. Values below half pi will be treated as the external angle. Okay. What is ink trap? The alternative ink trap coloring strategy is designed for better results with typefaces that use ink traps as a design feature. It guarantees that even if all edges that are shorter than both their neighboring edges are removed, the coloring remains consistent with the established rules. Okay, that's interesting because this tells me that it's not like an experimental feature or something like that. It's not like for weird. It's not for like situations that I'm guaranteed to not face. It's for specific kinds of fonts. I should look up what ink traps are. Let's take a look at coloring by distance, because this is the option that sets the configuration value to expensive coloring to be true. The alternative coloring by distance tries to use different colors for edges that are close together. This should theoretically be the best strategy on average. However, since it needs to compute the distance between all pairs of edges and perform a graph optimization task, it is much slower than the rest. Okay, so coloring by distance would be ideal from what I can read, but it's something that I would want to reserve for offline work. So, which, it's totally feasible that I might do that, because once I've got the editor working, and I've started working with asset files for import. Oh, hey, how's it going? Good morning, or good evening. I didn't see you pop in there. Just do it once it starts up. Easy. Yeah, that's the other thing I was going to say, is that I could just cache it at if I wanted to have a shipping game generate fonts at startup, I would just cache the result after first launch. That's totally doable. For the moment, though, because I'm not really doing robust asset management stuff right now, I'm just going to use edge coloring simple. Though, let me Google. I am going to Google ink trap. Oh, why does Visual Studio do this sometimes? It'll sometimes open up the right-click menu and then not close it when I go to another screen. I do want to know what this ink trap business is. Ink trap. There we go. An ink trap is a feature of certain typefaces designed for printing in small sizes. The corners details are removed from letter forms. Type is printed ink naturally spreads to. Okay, so there's a couple of fonts that might want this feature, but they seem to be pretty obscure. I guess the ink trap is literally for fonts that are designed for print, which you might have some game where that becomes important. Like if you have like a game where like you're reading like old-timey newspapers or something, you might want to use a font that does that. I'm not going to bother with it for now, but maybe in some future version of the engine we would do we would add an option in the API to allow for that coloring strategy, but for the moment let's not bother. Cool. So I'll head back to the algorithm that we're looking into. Edge coloring. So expensive coloring apparently is the algorithms that this is the switch that we see when we go to generate the atlas bitmap. So let's put that to the side for the moment and just take a look at the else. Unsigned long glyph seed, config.coloring seed. There's another configuration attribute we need to look up to see what it does. Glyph seed times LCG multiplier. It's a constant. I feel like I would recognize this number if I was more computer sciencey. Is this half the max number of unsigned longs? Scientific, or not scientific, programmer. Yeah, I'm not really sure I see the property here. I'm going to assume that for the moment that this is for log 2 the number. That's smart. Is it to see if it's a power 2 what the how many digits it is. And then I can do. Is there a way to do log 2 in this calculator? I suppose I could just Google it. 62.46. Oh yeah, Scientific probably has it. Yeah, so that would, yeah, okay. That doesn't really tell me anything actually, because it's not an even number. My presumption is that the constant is used for maybe like randomizing the glyph seed. So not quite ULL max, that's nearly long max, yeah. That's why I was thinking like, because it looks suspiciously like half of the maximum of long, which I recognized, or unsigned long. But yeah, I guess it's not quite there. Let's see how glyph seed is actually used. So glyph, this is a class for glyph geometry, which I actually have loaded from a font file in my example. Edge coloring applies coloring to the, does edge coloring apply coloring? Yeah, that's a helpful comment. So we use the edge coloring heuristic here. So this is a function pointer, I believe, to the method that actually does the coloring. This is angle threshold is probably set by. Let's find the console command that does it. Yeah, it's set by angle. Sets the minimum angle between adjacent edges to be considered a corner. So I'm presuming there's a default value for that. Yeah, default angle threshold, which is defined in the header here. So let me copy that over to my code. All right, and then glyph seed. So I'm just gonna quickly hop into edge coloring. So essentially it just calls the heuristic. It's a pass-through for the parameters that we provide. So in order to identify that, I need to identify the normal algorithm again. Oops. this guy, edge coloring simple. And let's see how seed is used. So we've got identify corners. Teardrop case. Multiple corners. Switch color to seed. What does switch color do? There's some I'm guessing that the seed must be like for quasi random stuff. The whole point of edge coloring is to make sure that each edge of a curve, or each edge of the glyph has its own color associated with it. There's a video clip I have been using. Trying to remember where it is. I was just looking at it. It was a GDC talk. Where a guy was presenting a paper. Rending. And I probably should just take a screenshot of it because I keep referring to that glyph. Here it is, shape decomposition for fucking ads. All right, here we go. Yeah, so this is a guy who did a demonstration of not this paper, I don't think, but a similar one to the one that this guy wrote. But it kind of demonstrates here that the whole point of the edge finding is to assign a color to edges that meet at corners. So when going through the list, he's having to pick which color is which. So I'm guessing the seed is just like a random number thing, that he wants to make sure that the edges are not completely random, but like that it is going to be a different color from the ones adjacent to it. I'm gonna trust his math there. Heading back through the code, edge coloring, angle threshold, glyph seed. Let's see how glyph seed is generated. So coloring seed, okay, yeah, so it sounds like for some reason or other, the console app allows you to specify your own seed. So maybe it might be like the case like you use this as a utility to produce the atlases, and then you inspect each atlas yourself, and you're like, okay, I don't actually like the edge coloring of that glyph. Let's do something else. That probably matters more when you're not using fonts, because you can actually also use this at the Atlas Packer. You can also use it to pack other glyphs that you generate using the MSDF algorithm. So if you wanted to have like a super clean, crisp logo for like a fictional, pseudoscience company or something like that in a game world, you want to make crisp, clean vector graphics, but you want to store them as MSDFs to make them cheap to render. Then I might care about the seed. But if you're in such a situation anyway, then you probably shouldn't be asking the engine to generate the glyphs for you. So I'm just going to use whatever the default is. So let's go to find out what the default is. Seed. Parse unsigned LL. Doesn't say no more occurrences in the document, really? But there must be. So Behind seed. If you don't pass in the seed using the console command, it kind of looks like it's literally uninitialized. Because there's the declaration inside of the configuration struct. The next mention of it is when you go to set it from the command line. And the next mention after that is when you go to use it. So I guess it just defaults to a 0 seed, which, if, seed, any seed is technically as good as any other. It's just a little weird to me that they didn't explicitly declare it 0 in the initializer, because that's technically the more correct thing to do. But yeah, uninitialized is probably fine for a seed. Okay. So I guess what this whole section boils down to is that I would call for every glyph in my glyphs, I'm gonna copy this back over here. For every glyph in my glyphs, glyph geometry, MSDF atlas, and actually do call my glyph vector glyphs, you can just pass it the simple edge. Oh, I forgot what it was called already. Or edge coloring symbol. Edge coloring. Really? It's not showing up? Is this a member of something? Oh, this is MSDF gen, not Atlas gen. Gen edge coloring simple. And then the angle threshold, the default was 3.0, but I'm just going to go ahead and keep using the macros to make it clear to me when I'm going back and studying my Frankenstein code. And then glyph seed can literally be anything. I'll just pass it as 0. Though interestingly, LCG multiplayer. LCG probably is a computer science acronym. Linear congruential generator. Algorithm that uses a sequence of pseudo-randomized numbers calculated with a discontinuous piecewise linear equation. This method, okay, so it is a part of the random number generation. But I guess that's why the value is not quite the maximum value for an unsigned long. You take whatever seed you plug in, 1, 2, 3, 4, 5, whatever, and it will just multiply it by a very high number that's not quite at the maximum, and you'll get wildly chaotic outputs from that multiplication due to integer overflow. But if the default is 0, then I don't actually need to do that. And I don't see any need for me to ever use a different seed, given that I'm just rendering fonts, so I'll just do it at 0. So yeah, we just go into the glyph, we set the edge coloring, so now each glyph contains its own edge coloring. Cool. All right, so it seems like that's the next step and we're ready to move on from it. All right, so we've done the edge coloring for the multicolored stuff. And now we take a look at the actual atlas generation, which should be the last, it's at least the last thing for the texture generation, and we still have to get the data out for creating the actual text. So like we need the sample values to use, the UVs to use in the texture. We need the kerning and width and the height of the characters so that we can assemble strings of text using quads and so on. So we're only interested in these guys, the MSDF and the MTSDF. If floating point format, make atlas with float, otherwise make it with byte. Okay. Float. Okay, this actually looks like a pretty easy to understand call. So make atlas, you pass it the glyphs, the fonts, though, oh, hang on a moment. What? Oh, this is not, yeah, this is not a API call. Never mind. This is a helper method concealing the work that I need to do myself. This is actually declared as a helper method in main.cpp. Okay, so that's easy to read, but the signature is easy to read, but this isn't quite under the hood quite yet. Immediate atlas generator. Which is an API structure. So I was looking at this earlier. When I was going through the API, just like looking through the headers, I had identified this as likely something I would need. Immediate atlas generator is one of a handful of types of generators provided by the library. You can either do the entire atlas generation at one time, where you know in advance all the characters in the glyphs that will go into it, or you can do it like piecewise. You feed on an ongoing basis more glyphs into the generator, and it will continue to pack as you go. But I was confused by all the template parameters it needed. So here's a working example. An implementation of Atlas generator that uses the specified generator function, and Atlas storage class generates glyph bitmaps immediately, does not return until all submitted work is finished, but may use multiple threads, set thread count. That's a parameter, I'm assuming. Const. Except I don't see it. Generator with height. So set thread counts done down here. Okay. Let me head back to where this was invoked from, make sure that I'm understanding it correctly. Let me investigate this floating point format variable. Okay, so if we are outputting with TIFF, text float, binary float, or whatever, then we use floating point. I'm using PNG style formatting. I'm technically not outputting to a texture, or not outputting to a PNG file, but I do use SDF, what is it, SDF, or SPD. I forget the image library that I'm using. STB image, the header one that's really popular. And if I go to my texture code, textures.cpp, Yeah, that literally will load in as yeah, it loads in as byte values, except for if you want to do HDR stuff. So I'll just use the byte version instead. All right, cool. And back to where we were. Loading glyphs, generate bitmaps, make atlas for glyphs, fonts config. So yeah, these are literally identical calls, with the exception that the third parameter is either 3 or 4, depending on whether I want the transparency. All right. So the first thing that they do is they make an immediate atlas generator. I'm going to copy this into my own code and make some modifications. Immediate atlas generator. The second parameter being float. The second parameter being, wait, what? Hang on a second. Second, first, or second, third. Where's T used? Oh, T is used at Bitmap Atlas storage later on. So N is 1, 2, 3. The third. So N is the number of things. So we'll do is MS or MTSDF. We'll do 4 if it's got the transparency. Oops. 4 if it's got the transparency, or 3 if it doesn't. And I'll set this as a true for the moment, or false for the moment. And then, why don't you? Oh. There we go. The gen function in this case is the 1, 2, 3, 4, the fourth method, which is, or the fourth template parameter. Oh man, it's hard to sometimes follow all this stuff going on. All right, so that would be gen bitmap atlas storage is what we would use, and T I remember is a byte type, and N is the number. Yeah, N is that number. Wait, what? Oh, I didn't replace the previous. So T is I think it said byte, but I don't think it's using the std byte. I think it's using its own type. Yeah, type def unsigned car byte is what they're using. Right? Wait, types.h. Yeah, this is their own type def. So I would use, first let me put this in MSDF atlas, and we would use unsigned car. What's going on? Type name not allowed. Of course the type name is allowed, it's a template. Oh, it's the N. That needs to be replaced with 4 or 3, depending on what mood we're in. I've forgotten something. So we got float, 4 or 3. Oh, is this an MSDF gen? No, it's Atlas. So MSDF Atlas, unsigned car3. Oh, that needs to be, are they declaring it right there? Hang on a moment. I think they might be instantiating it and then bringing it in. So we go to make Atlas, passing in MSTDF generator. So this is MSTDF generator is the 3rd parameter of make Atlas. That's not right. 1, 2, it's the 4th parameter. 1, 2, 3, 4. So generator function SN. Oh, so actually I don't need to oh, that's a function pointer. Okay, so I need to actually use the default. Which is this guy, I guess. Actually, it looks like there's 2 different ones. Okay, let me slot that in. So MSDF generator, if we're using 3, otherwise we're using MT SDF generator. And then glyphs fonts config. All this extra wrapping of stuff is making it really hard to parse this API. It's driving me nuts. There's because this helper function, I don't know, it might have helped the developer organize their code when they were making this, because now they can just do make Atlas whatever. But these config values, there's literally only ever one instance of the config value, and its only point is to house the values that you type in. These could just be variables. They could they don't have to be struct members. You don't have to make an object just to contain your config stuff. You don't have to pass them around if everything is in main.cpp. So it's I don't know. That's driving me nuts right now because it's making it way harder for me to follow what's happening. Float or byte float 3 MSDF generator. Okay. So yeah, the first thing we do is we do float, or S is float. Fuck. Yeah, S is float. N is the number of attributes we want. Gen function is the function we pass in. So actually, that should be the 3rd parameter. Float is MSDF. Okay, good. And then there's one more parameter, which is Atlas storage. Bitmap Atlas storage. That's what we do. Bitmap Atlas storage. Unsigned car. Okay. And then 3, 4, or 3, depending on the type. Oh, except for I need to put these in the right namespace. There's multiple namespaces going on in this library, so I'm having to, I don't want to have them pollute the global namespace. Yeah, but this way everything is encapsulated. It provides a good object orientation, and it eliminates fragile global state. Yeah, exactly. Yeah, all those. I don't know. I think object-oriented stuff is I think there's a lot of developers out there now. There's like a movement for folks that think that it's the devil. I don't necessarily think object-oriented is the devil. I just think that this is an inappropriate use of it. So this would be, I'm assuming it's in the Atlas namespace. No. Is it? It is. It's in Atlas. All brand types are incompatible. Are they, though? Like if I just put the one by itself. Oh, that's interesting. I must be using the template wrong. So you got the first type is float. The second type is the number of parameter, or the number of components. The generation function, heading back to where it was used. The generation function is either MSDF generator or MTSDF generator. Did I mistype one of these? No? Well, then you are wrong. OOP is clearly the source of all evil, not the shitty design patterns and best practice that is taken completely out of context and not used to actually help improve code. In any measurable objective sense, there are definitely examples of best practice that are very useful. Disallowing null pointers, for example, helps ensure that you think about sensible default values and avoid sick faults. Immutable by default is also quite neat. Yeah, I mean, like, I'm not, I've said this several times before. I'm definitely not classically trained, so I don't know all the design paradigms that are classically taught. But yeah, it's definitely like, if you prioritize, readability, maintainability, and all that stuff that's important in good code, then you just find that like object-oriented shouldn't be used as much as it is. And I can see that myself. But clean code is a scuffed idea that should be completely scrapped. I'm unsure if you are sarcastic when you say that clean code should be completely scrapped, because like clean code would help me a lot reading this code right now. Right? Maybe clean code means something different to you than the way that I'm using it, in the sense of readability. Like, I don't consider the way that this is programmed, I don't consider this clean code, even though it looks like it's, I think it's just obfuscating and making it harder to read. Yeah, so like, I guess there's another sense that you might mean clean code, but the way that I think of clean code, I think of it like, can I just look at it and understand what's going on? The only clean code that you'll ever see is your own. Yeah, I mean, maybe that's potentially subjective, but I don't know. I think that like the make atlas helper function is not necessarily an example of the bad code, but this configuration struct definitely is. These should just be global, and you shouldn't be like. What he does is he like creates an instance of it down here for use in the main function, and every time he goes to set the image type format, whatever, he's always doing config dot. And so, yeah, I don't know. It's just a whole bunch of extra dereferencing that I have to consider. Because then he does something like pass the whole thing into this method, and then I can't just see like how it's used. I just had to like when I'm trying to parse the function signature, I have to like ignore everything that says config whatever, because I already know that there's only one instance of it. I don't know. And formatting and styling does nothing to actually accomplish what your code's meant to do. Sure, it's just a human thing. It's something that makes it easier to go back and fix your code later. I don't know. I do think it's an important step to make sure that your code can be read by another programmer. If you're working on a project that potentially you'll be working on over the course of years, you want to be able to come back and like jump right in instead of having to say, "Oh, what was I thinking?" For 20 minutes. But this is why we should reinvent the wheel and constantly and write our own libraries. Yeah, I guess so. I guess. Anyway, I think I'm getting sidetracked. Let me figure out where I was. So I was in the middle of getting my own immediate atlas generator working. So I know that the first parameter is float, though I'm honestly not fully understanding why. Because I'm storing I'm ultimately storing the data as bytes. That way we all know what's going on under the hood and they will all be styled properly. Yeah, sorry for that. No, it's cool. This is a rant safe space. So I need to figure out what's up with this 1, 2, 3, third parameter. For the moment, I'm just going to take out this MSDF stuff checker. I'm just going to assume that we're only doing MSDF in here and read what's going on. Well, that's interesting. It cleared right up when I did that, suggesting that maybe it doesn't like the ternary operator. Still a problem with Bitmap atlas storage, though. Spencer would like to know your location. I'm imagining a little pop down on the corner of the screen that's like an app on or a website on Google Chrome. Ben Shapiro would like to know your location. Oh, Bitmap atlas storage actually is I have to put it in the card scope. MSDF atlas Bitmap atlas storage. Okay. So that might actually be the entirety of the problem. Okay, then we got width, then we got height. Right? Or is that not enough? I've got a width and height. Don't I? Oh, I set that down in here. Oh, I'm an idiot. This needs to go down below. When I originally cut and pasted, I put it in the wrong section. Yeah, so now we've got, so this is the loop that gives you the geometry. the packer packed in all the it gave me the actual dimensions that I need for the atlas. And I pass it in here. Okay, so this gives me a class then that I can use to get the texture atlas, I guess. Let's head back down to how, well actually we're still in the helper function. Here. So creates the generator, calls set attributes, set thread count, and generate. And then you access the storage using a reference type. Constant reference to a 2D image bitmap or buffer acting as one. Okay. And then it's at that point that they will write it out to file, I'm assuming. So save image, takes in the image format and actually writes it out. Okay, cool. All right, so I think that's where we're at then. I just need to set the attributes, the thread count, and call the generate call. I think I'm kind of figuring out how this API works. I think that after this is done, I'm probably gonna want to write a small tutorial, make a small video tutorial covering this API, because like I wouldn't have to be going through all this parsing work if the Atlas Gen actually documented the API, so that you could just read how you're supposed to use it. And for some reason, nobody on the internet's made a tutorial quite yet. Immediate Atlas generator, full 3. Yep. Oh, except for I didn't give it a name. Generator dot set attributes, and what are attributes? Config dot generator attributes dot config dot generator attributes dot config. Yeah, that's not hard to read. Config preprocessed geometry. So apparently there's a couple of members of this class. So this is like a wrapper class for things that you need to pass to the generator, which this might get a little chunky. So there's error correction. Error correction is an option that's offered by the console. Error correction mode selects the error correction algorithm. Use help as mode for more information. So I guess we'll get a description here somewhere. Help. Error correction help text. All right, here we go. Error correction modes: autofast detects inversion artifacts and distance errors that do not affect edges by range testing. Autofall, that do not affect edges by exact distance evaluation. Detects inversions by distance evaluation. And distance errors that do not affect edges by range testing. Disables error correction. Distance fast. There's a whole bunch of these. Is there a default? Oh, okay. So generator attributes has, so it's a class that contains just the MSDN versions, MSDF gen library's own version of the configuration class plus a Boolean. That's all it is. Okay. And then it contains another struct that contains more configuration data. That's 4 levels deep. Oh my god. And each level is only just like adding one thing. Oh my god. All right, let's make sure I'm not overlooking something. So we call set attributes on the Atlas generator. And this is the part of the API that I'm trying to use, so I actually do have to create a generator attributes. Generator attributes just contains an MSDF generator config class and a Boolean. And the generator config just contains an error correction config and a couple of inline helper functions. And the error correction config contains some data. Oh my gosh. The proper object structure and clearly if the author wrote it that way, it just makes sense. Yeah. There is one level of this that I think is maybe acceptable. Believe it or not, that's the first level because MSDF generator config is part of what is technically a separate library. So you can make an argument, that may be this, but you can also make the argument that maybe just make this a parameter wherever you would, like wherever you need it in the actual library. It's just a Boolean. But from here on, going in and in, all this stuff is within the same library. It's all within MSDF gen. So, Jesus. Anyway, so I guess I need to create a generator attributes. I don't know what scanline pass is. Scanline performs an additional scanline pass to fix the signs of the distances. So it's like a post operation. That's interesting. So this suggests that if you don't do the scanline pass, that the signs of the distances might be wrong, which, that means it's a broken MSDF. So I do want that. The generator attributes. Here we go. Generator config, error correction config. Wait a second, it's even worse because it's just helper functions. Oh, whatever. Maybe I can use this helper function. Inline explicit, MSDF generator config, overlap support. So let's see how in the actual library, or in the actual console app that we're learning the API from, let's see how they determine it. So config.generator attributes. Okay, so here's the first mention. That's in the helper function. So here's the first mention in the main function. We set overlap support to be the opposite of pre process geometry. And we pre-process geometry if we're using Skia. Okay, the pre-process pass apparently resolves self-intersections and overlapping contours, so that's apparently important. So I will want pre-process geometry would be true if I was using this style, which means that I want my overlap support to be false. And scanline pass as well would be false. Okay. So let me make myself an attributes class. MSDF atlas generator attributes. We'll do attributes dot scanline pass equals false, and then attributes dot config dot overlap support equals false. Because we want to pre-process geometry. And then there's error correction, and that is set with a crazy if statement. All right, so config.generatorAttributes.config.error correction. But error correction is what we're trying to set. Oh, we're just getting the address of it. Okay. Or we're just getting a reference of it. I just wasn't paying attention. So, ec.mode. So we're setting two things, mode and distance check mode, depending on what we apply. So if error correction default is what I'll use. Else if string compare default, or auto mixed, or mixed. Okay, so there's a handful of options that I can set this. We set mode to edge priority. Okay, that's good. And then distance check mode equal to check distance at edge. Okay. Then what else? So it looks like if we don't set it from the command line, then explicit error correction mode equals false. So let's see what happens if it does equal false. So here where this is a phase of the console application that seems to be taking the user input and then filling in the holes of what attributes they didn't provide. So if explicit error correction mode and config that doesn't check mode does not equal do not check distance. Okay, so that's not related to what I'm looking for. So it's only, so I guess its only purpose is to handle the situation where somebody set do not check distance, in which case fallback mode name equals disabled. I'm guessing this is more console stuff that we would fallback mode name, probably something that's printed out to the console or to a file later. So I am okay with that. Okay, moving on. We also need to set error correction min deviation ratio. What is that? That's interesting. So apparently this is set using a command line option that is not documented in the API here. Which, great. Let me see if I can find the help text for it. Sets the minimum ratio between the pre-correction distance error and the post-correction distance error. I don't know what that means. I don't think I care though. So, what would be the default for an improve ratio? It's literally only set here. So let's see what EIR is, parse double. So I guess min improvement and min deviation ratio, we just use their default values. Which here, default. So there is a default. It's set in the constructor, and it's set to 1.111111. I wonder why that is, but it's floating point, so it's more of an art than a science when you're talking about measuring distances. So yeah, when I go to create the generator attributes with the default constructor, it uses the generator config's default constructor. Which uses its default constructor. Cool, which sets the deviation mode to be what I want. Oh, and this is gonna make me a little bit mad. It actually looks like it automatically also sets the other values to the default. So I don't actually have to manually specify anything, which is great for actually using the API, but it means that I spent a while parsing through code that doesn't even apply to me. All right. So if that's the case, then in here, when I go to make the generator attributes, they are already set to the default. So the default would be to use edge priority and edge at a distance, is what I saw. Scanline pass is set in the parent object. Here and its default is to false already, so I can take that out of my initialization code. Scanline pass default. It's just for some reason the console app explicitly sets them, even like to their default values, even though they have default values. And then overlap support. Overlap support has a default value of true, which is interesting because the default value that I had found reading through the console code was false. Maybe I misread something. Overlap support. So you can explicitly say no overlap or overlap. If you don't, the default is the opposite of preprocessed geometry, which is true if you're using Skia. Okay, and you can also explicitly set preprocessed geometry to true or false from the command line. So it must be used somewhere else as well. So it's used in the load glyphs loop. So if I go to my load glyphs loop, here, I can get rid of all that now. I set preprocessed geometry to true and enable kerning to true, which they are true by default. So I don't get it then. Is it possible to turn on preprocessed geometry yet turn overlap support on? Because the fact that the overlap support is initialized to the opposite of preprocessed geometry suggests that they are orthogonal options. So overlap switches to distance field generator with support for overlapping contours. Disables path disables path preprocessing, which resolves self-intersections and overlapping contours. Oh, okay, I guess that makes sense. So you could totally run the overlap field generator if you want, but because the preprocessing step already resolves self-intersections and interlapping contours, there's little point. So in my case, yes, I would want to turn overlap support off. By default. Even though in the actual class, overlap support is set to true by default. So this is going to be maybe set to false to improve performance when no such contours are present. And because I'm using pre-process, we have them already resolved before we get to the main pass. Okay, cool. I'm getting it. Sort of. All right. Scanline pass is off by default anyway. Okay. Let's head back up to that helper function, make atlas. Okay, so now it looks like I've got my attributes fully set to the defaults plus that one modification that makes sense in my case. Error correction has some members that apparently don't matter because they'll just be using the defaults anyway. An optional buffer to avoid dynamic allocation must have at least as many bytes as the MSDF has pixels. That's interesting. I'll put that on the back burner for the moment. Even in the worst case scenario, I will only be using this library at launch. So like the worst case scenario for me would be when I go to generate the texture atlas, when I go to load the font. So that's only going to be done. For now, it's going to be done at the start of the application launch. Later on, it'll be done at the start of loading each level that has the text asset. And in a shipping game, I would bake those anyway, probably. Actually, I wouldn't bake them. I would have to cache them because I don't know, like for like region reasons. I might need to have the character set be changed depending on the region that you're in which case we wouldn't want to pre-bake that stuff. We would want to have that generated on the user's machine, but we would cache the results the first time it's done, so that way subsequent runs of the game, you're not generating these every time you load the level. And ideally, you would want to push that to the first launch of the application, so that you're doing it alongside shader compilation, for example. Okay. So that tells me I can just plug in the attributes here. The thread count, I don't know. I'm assuming 8's a good number, but I don't know what the default is for the situation. Let's find out what they set for thread count by default. So it starts out equal to 0. If you specify threads, you can specify a number directly. If thread count is less than or equal to 0, then thread count will be SD max from the standard template library, thread hardware concur. Well, it's not template library, but standard library thread hardware concurrency. So it just automatically picks out the max. So I'll just go ahead and use that. Sounds good to me. Expected a yeah. And I think I'm sure I've got thread in my headers somewhere. CH. Well, actually, I don't. But I do include the Atlas Gen header, which will, on its own, by merit of including these headers. Or maybe not. Maybe Visual Studio is just not telling me that I need to include thread. If I need to include thread when I go to compile this, I'll just do it then. Generator, generate, glyphs.data, glyphs.size. Good. Okay, so I think that's that. I've got all the default values set up here for generating an MSDF. And I generate it. So now it's stored in the generator buffer. So generator dot Atlas storage, I guess. Get XY. What is get? Is it a sampler? XY, bitmap ref. Yeah, okay. Cool. So now just a matter of getting this stored into a texture and sent over to the graphics card. So MSDF gen, bitmap const reference type T, type N, which in the context of the helper function I stole this from, is, here we go. We're not using artery fonts. Okay, so T is always passed in this float for some reason. I'm not clear on why. And then N is the number of attributes. Why is T always Oh, no, it's not. T, so I got them backwards. Okay, so actually I do need that to be the byte type. Okay. Yeah, I thought that was weird. So that needs to be unsigned car. I'm not going to use their type def for byte because everybody's got a type def for byte. And then there's another place over here. Immediate Atlas generator. Or maybe it was this. Maybe I was just confusing the... S is the second parameter, which is 3. Oh boy, I think I am losing losing track. Clearly, the only type of type defs, the only correct set of type defs are your own. Yeah. U8, U16, U32, U64. Yeah, those are nice. They're very commonplace. U8, U16, U32. I think that if I was to specify my own type defs, that's probably what I would name them. And all kinds of companies name those exact things. But yeah, in my case, I generally will just use the standard C++ type. So I'll use uint 64t if I want a uint 64t. There's also, uint 64_t to say the fixed 64-bit width integer unsigned. There's a type def for already. Technically, it's a type def. I think it's implemented as a type def. But it's so long. Yeah, I don't know. I don't know if that's enough of a reason for me to specify my own type def and then like risk a conflict with somebody else's library that also did that type def. I might change my tune, the more I program, because again, I'm not a professional programmer, so I don't. Yeah, it is, and custom versions are just type defs of type defs. Yeah. I don't know. For me, I just don't care enough. It's not a deal breaker for me. So the type here is clearly supposed to be the byte type in my code. But I think, this one takes the second parameter for the make atlas. So let's head back to where we use make atlas. Yeah, and the second, okay, and that's where I was getting confused. The second parameter is always float for some reason. And I'm not gonna invest the time to figure out why. I'm just gonna go ahead and use it. So that needs to be float. This needs to be inside car. All right. And Bitmap Atlas storage does inside car as well. Okay. Okay, and so this would be unsigned car, and then this would be 3. Right now I'm just writing it for the MSDF instead of MTSDF, which I will do an option for later. Generator atlas storage. So this takes out the atlas that was generated by immediate atlas generator. Okay, so apparently Bitmap can be used places. So I've got a height, a width, and pixels. Oh boy. Okay, I think I've got it. So I'm assuming that the pixels are just the buffer. T-type. MSDF gen byte 3. Okay, so pixels are blocks of 3 bytes. So I can use this, I believe, to generate myself a texture. Sweet. Are you taking off? Yeah, dude. Thanks. Yeah, I think I'm getting to the point where I'm doing exciting stuff now, so I'm almost there. But a whole lot of learning to go. Have a great night. And here we go. So now I've got the width and height of the bitmap, and I have the generated bitmap. So let me go ahead and generate a texture from it. This will have to be handled a little differently from the way I do textures before, because when I do the load texture from the file, I'm using stbi to get the texture, and I'm also setting minification and magnification filters that, in the case of font rendering, are constant. They're always going to be linear or bilinear for the magnification, And for minification, I suppose minification would also be linear with bitmaps. Right? Right. So what I'm going to do, I usually don't like doing this, but I will in this case, because this is my own code and it's pretty readable. I'm just going to copy the whole thing and then just take out the stuff I don't want. So for starters, I don't need this anymore. I'll keep it in the braces just for the sake of being able to read it. In the future, I might make a non-OpenGL version of this, but if and when I do that, it'll be in the form of making an alternative CPP file. So I'll just do OpenGL code directly from here. So we've got a GLUint texture, which will hold the texture handle when we're done. In the actual case of binding textures in the from textures loaded from PNG files, I did a reference tracking system by which I would not load the same texture twice. I'll do something similar here. I'll throw it at the top. We'll do static MSDF. Ugh, I might need more coffee. Yeah, I'll do MSDF reference count. That'll be an STD map associating the hash name of the path to the font file with an unsigned int, representing the count. So we'll do MSDF reference count. And I'll wrap this whole method with it. If MSDF reference count hash of path is greater than 0, then we will do all the things that we spent forever programming. Else, oh wait, what am I saying? So yeah, I want it to be the other way around. So if it's greater than 0, then we just return the reference. Else, we will load it. Return. I'll also need to store the there we go. And I'll put this in the enterprise namespace to save me a little bit of typing. Okay, now we've got texture handles as well. So if we have a reference, then we'll say return MSDF texture handles at hash of path. Yeah. Else we will generate one. So I'll worry about the rest of the logic later. But I need the texture right here, and I can get rid of this extra block now that I have an equivalent version of it. You know, I was just looking at this code that I copied over, and I'm realizing there was an uncaught bug in this frickin' texture loading code. I've got erase hash name and put path in quotes when that's actually a variable name. Okay, let me fix that. That's interesting. That should not be there. That should be like that. Yeah, replace. Yeah. Okay. Interesting. I guess I just never ran into the situation. I suppose I wouldn't have run into the situation where I need to load something that where I need to delete a texture to load another level. So yeah, let me save that. Good. And then heading back to this code. I no longer need that else block. I can also get rid of the logic there for returning references, which I'll deal with later. So in this case, we just did STBI to load the thing. We already have the width and height, and we already have the number of color components. And we already have the buffer. So after we call generate, I do need to do some checking to make sure that the generation worked correctly. I want to confirm with the use in the API that everything worked okay. Interestingly, the generate call doesn't have checking following it. It just makes the ref, sets success to true. Oh, that's the default value. Okay, I'm just being tired. So if config.image file name, meaning we've specified a file, the file name to save to, versus doing an artery file name. So this is always going to be true in the branch that I'm considering. If save image, bitmap, image config format, file name, y direction, else set success equal to false. So we actually don't do a check on the validity of the bitmap. We just try to save, and then if it returns false, we know that it didn't work. And I'm hopping into the save image because I suspect that it has its own check on bitmap. So vector, pixels, bitmap, width times height. Interestingly, it takes and instead of doing a C-style iteration, it just takes and constructs a vector of bytes. That's silly, but whatever. So it constructs a vector of bytes and then does a memcopy to it. Maybe encode has got a check. load PNG, get raw size, LCT. So this method here actually calculates the size of the data from the width and the height. And if the size is 0, then, or if the size is greater than n.size, then we return 84, which I'm assuming is an error code. Having to dive through a whole bunch of nested methods to it looks like they check a number of things to make sure that the data is correct. But the most important one that I can see is that it requires the size of the returned bytes to be it requires the size of the bytes to be greater than 0. So I'm presuming that upon return, that's the error condition that I need to check. So at this point, I would say if bitmap.pixels.size, or is that literally just a it's just a byte pointer. So actually it would be bitmap.width, which is not a getter. Yeah, public int and public height. So width times height, then if that's greater than 0, then we've got a texture technically. Then we'll do the rest. Okay, enough. All right, and then for now, I will not be using. Actually, why not? Let me go ahead and do a valid path. So let me, in the load font function, I'll use the file system's virtual. Am I not in the Namespace Enterprise? Oh, I guess I am. I just haven't included the file system. So file virtual path to native path. No suitable function from std string to const car pointer exists. All right, fair enough. Oops. Well, hang on a moment. Why not? Oh, it's because I don't have a const version of this method. I suppose I wouldn't. It's always going to be an R value. Yeah, so I'll need to do a string on the stack here and use it. Because virtual path to native takes and does some string concatenation, produces a string, that's going to be an R value, which means that it'll, if I was to use it in the parameter directly and then call cstring on it, it would result in a pointer to memory that might go away later down the road, and I don't actually know if float font like holds on to the memory, so, or the memory address, so I'm just gonna declare it up here and then use it down here. I should probably have my own I should probably do my own check for whether the file exists to give my own warning, but I'll put that on the back burner because this is already a whole bunch of code that I don't fully understand. Load font, load glyset. Okay. Yeah, and let's head back down to the other stuff. So we're not doing the load, the existence check anymore. So STBI, we do the load into memory. We already have all this data. Instead of doing if buffer, we will do if width times height. I don't know whether I am guaranteed to get a null pointer or a bad pointer if we check the bitmap dot whatever. So I'll just do width times height for the moment. So that can go away. I don't know offhand whether the data that comes in will be bottom to top or top to bottom. I think there's a way you can set that in the library. I think I saw, but I'll worry about that later. I have a check here to see if we're doing a 1x1 texture. That'll never happen in this case. It'll always be or sorry, not a 1x1, a 1x something texture. The idea is that in my actual texture loader, I support one-dimensional textures. And so when I go to create the texture on OpenGL, I can either do texture 1D or texture 2D. In this case, it will always be texture 2D. So I'll get rid of that. Let me just quickly do some find and replace. Okay. Get rid of that. So the first thing we do is we do GL gen textures, pointing to the address of the GLU uint that will receive it. Then we bind it to texture 2D. Yeah, that can just go right up here. And then switch for a min filter. In this case, I will always be using linear because that's the entire point of MSDFs, is that they are linearly interpolated. Though that actually leaves a decent question. For minification, I'll be using MIP levels to handle the interpolation. I think the way that I've got map. Don't I do bitmap mode? Yeah, bitmap mode. Bitmap mode can be none, nearest, or linear. So yeah, so I would in the minification filter, I would still need to do linear. Because nearest would give you kind of a shimmering effect still. But the bitmap mode has its own linear, which means that it'll linearly go from one MIP level to another. Most of the time I'll be looking at textures in much bigger, using the magnification filter. I think I will just assume that linear minification is fine if somebody is looking at text that's just one pixel or whatever, because like if you're looking at like a block of text from a far distance, or like it's really small, it might be a lot more noticeable to see aliasing across the entire block of text. So I'm gonna just make the executive call to do linear, both on the MIP mapping and linear on the sampler or the filter. I scrolled right past it, didn't I? Okay, here we go. Switch minification filter. We are going to do linear always. So let's copy that and paste it there. And then we can get rid of this whole switch block. And we do a similar thing for this, where we do you know what? There's a question here. There's a question about linear versus anisotropic on the magnification filter. I don't actually support anisotropic filtering yet. I just haven't bothered to add the OpenGL extension that does it. But when you're looking at text at an angle, that can be important. So do I want to just bake that into the API? Because there's plenty of cases where I won't be using it. Like most of the time when you're using, like the main use case of text in like user interface stuff will tend to be you're looking at it dead on anyway. So I may want to make that optional. So what I'll do is I'll go ahead and leave it linear right now. I'll say to add support for anisotropic. And maybe what I'll do is in this API I'll just do like a bool parameter that says if you set it to true, then it'll do anisotropic filtering. But we'll deal with that later. Okay, and what's this EPGL? I need OpenGL helpers. Whoops. There's a wrapper I have for OpenGL calls, EPGL. The purpose of which is to give me error checking. And the reason why I have to do it this way instead of the modern OpenGL way is because on Mac I am limited to OpenGL 4.1. 4.2 and later was never added to Mac OS, so yeah. So I have to do it the old school way of actually like calling the GL get error and then doing the switch case on, yeah, fun stuff. And Has support for anisotropic. Good. So magnification filter is done. And then wrap modes doesn't apply in the case of the font atlas because you're never going to be sampling beyond the edge. Or at least you shouldn't, because I'm not doing any padding in between glyphs. And if you're reading far enough out from the character that you might want to wrap around, it will only wrap around on whichever edge is close enough to you. So this doesn't matter. I just use clamped edge by default. So this case doesn't matter. This one does. So switch for a number of components. Right now I'm only doing 3 components, but I might do a 4th at some point. So what I'll do is I'll take these both and then comment out the one that doesn't matter. Oops. Okay, because we're only going to be doing the 3 component at the moment. GL texture 2D, 0, width height is 16-bit. Oh, that's interesting. Well, it should be 8-bit every time, because we're reading in the colors as single bytes. So yeah, 16 in PNGs you can get wider color ranges, 16 byte technically. So in my texture checker, I use in my texture loader I use a bool to track whether STB image determined that the file contains a high color range texture. What's the problem now? Identifier buffer is undefined. Oh right, I gotta do width and height and stuff differently. So width is actually something I already got from the packer. I now need to get the buffer from bitmap dot pixels. Right? Yeah, it's just a pointer. So that'll work. But now that I'm thinking about it, I actually need to do bitmap width and bitmap height instead of width and height, because I don't know if there shouldn't be any differences between what I calculated in the generator and the tight atlas packer. Because I'm providing the width and height from before, but just to be more exact, I'm gonna specify from the actual bitmap buffer. Okay. Cool, and then sampler needed for texture is sampler 2D. Oh, that's interesting. Okay. I actually do need to worry about this. In the actual textures.cpp, I track the kind of sampler needed for every texture handle. And I use that when I go to bind the texture, because you never know if the shader that you're using, if you're trying to bind to a sampler uniform, you need to have some protection against whether you're using the improper kind of sampler uniform. Oh, game Devla is big is rating with a party of 9. Oh, thanks. Hi, everybody. This is the second time I've been rated. I don't know what people enjoy about my channel, but they do, I guess. I'm working on a game engine. Right now I'm working on integrating MSDF texture atlases, so I can do multi-channel sign distance field text rendering, which is really cool because it's you take a letter that's like a super low resolution texture atlas. You can start in like something as small as this and get like super crisp, clean edges from it. So there's a lot of data work, and I'm nearly done with the texture generation part. Sampler type needed for texture, yeah. So I need to track this somehow. Presently, I track this within my textures.cpp file as a static map. But now I have a need to use it in another translation unit. I have a rule to not do OpenGL stuff in my headers because if and when I go to support DirectX and Metal, I want to be able to just do an if-def within the CPP files and just do an alternate CPP file depending on which API I'm using. So that's kind of led to this sort of hacky solution that if I'm in a situation where I need to use GL types in in another translation unit, like I need to share them, I just don't put it in a header. I just make it an extern. I'm afraid that's what I'm gonna have to do here in this case. I might reevaluate this down the road, depending on how maintainable this becomes. I've only had to do it a couple of times, literally for things in this file, because there are a few rare cases where I need to know OpenGL specific data in another file, and I don't want to put that in a header and lock in the API to considering the OpenGL format. So let me do that now. So I do need to put this in another file. So I guess what I'll do is I'll make the main one here, and then I'll do the extern version in fontatlas.cpp. And I'll do that. What scope was it in? It was in the global scope. All right. There we go. Extern, and in this case, I'll have to do enterprise graphics. Cool. All right. And then down in the code where we were working, I can now do this. Cool. And now there's an association with this texture with the GL sampler 2D, so that when I go to validate the sampler type in my GLSL shader, it will correctly say this needs to be a sampler 2D. Good. Okay. Now what's left is bitmaps. So referencing my texture code for PNG textures. Bitmap mode was a setting provided to my texture call. We're always going to be using bitmaps, so if it doesn't equal none, then we need to generate them. So that looks like so. There's an extra check here for bitmaps generated for non-power2 textures. I will keep that. I have it commented out for, or I have it conditionalized for non-distribution builds. So this warning will appear in the developer build for when you're playtesting your game and you're trying to test code at representative speeds, or you're working in the editor or something like that. This will work in the debug build, but if you're on the distribution build, there's no need to check because you're assumed to have caught all of your problems before you ship your game. And then GL generate bitmap. Cool. And I'll put that all down here. Now width and height. I need to make these bitmap.width and bitmap.height technically, because this is the data that I'm actually sending to the GPU. A little wordy, but basically it's just saying if bitmap.width bit shifted together with bitmap .width minus 1 is not equal to 0, and bitmap.height and bitmap.height minus 1 bit shifted together is not 0. If these are power of 2 textures, then you subtract 1 from a power of 2 number. It'll give you all zeros, except for the last digit. If I'm remembering right, I forget. I figured out this math a while ago, but it works, trust me. And then we gotta change this to be graphics load. Oops. Load. What did I call this method? Load font file. Well, actually, now that I'm thinking about it, I don't have to do this check at all, because using the API for packing the texture atlas, I constrained it to only consider power of 2 textures. So yeah, actually, I can just get rid of that check. That's better. And then down here, we would just do generate bitmap for the currently bound texture 2D, so that's good. And now we have to unbind the texture. And then in the case of freeing the memory, that's actually not a concern here, because that is handled by the bitmap ref going out of scope, I believe. Bitmap const ref. Wait, no, that's just a ref. So the data that it is pointing to, generator.atlas storage. Storage is another crazy long templated type. Called atlas storage. Oh, it's the class itself is a template. So when I do my immediate atlas generator, the last templated member is so bitmap atlas storage is what I'm using. And I just need to confirm that it actually cleans up the memory. And because there's no manual for this API, I have to dumpster dive and figure it out for myself. I thought I had defined use CPP11. Did I not? Okay, so I did define it in MSDF gen, the main library, but I didn't define it in MSDF Atlas gen. I guess this is just a constructor I don't necessarily need. If it becomes a problem, I might switch this on, but yeah, but it makes some things explicit that should probably be explicit. I might turn that switch on later, but I'll put that on the back burner. So the data is actually stored here as just a pointer of pixels. There is a destructor I saw, but okay, yeah. So the class, the class that's underlying the class that's underlying the reference, actually does have a destructor that calls delete upon the pixel data. So I don't need to free it myself. Wow, that was hard to hard to get to the bottom of. So in my own code, I can just let the thing go out of scope, and it'll clean up the memory. So I don't need to bother freeing. I can just do the bind texture to 0, and that'll be that. Now, current slot of texture equals -1, handle textures by path. That also matters. That kind of matters. Texture handles by path is a way to look up the texture given, or the texture handle given its path. Yeah, so actually I do need that to be, in here. Are these already externs? Texture handles by path. No, I had to expose sampler uniform locations and sampler uniform types to handle bindings. So I do, whenever I do sampler uniforms, when I go to bind a texture or bind an attribute in some cases, I do need to have access to this information, but I haven't until now needed to have this stuff become available. So I guess I'll go ahead and make it external. I need path of texture handle, current slot of texture path handles by path of texture handle. So these two need to be no longer static. And then current slot of texture is already available by extern. Cool, so let's get these in here. I am getting a little more uncomfortable with how many externs I am using, because originally I was only doing like 1 or 2 externs for the texture stuff, but now I've got like 5. So if I do many more of these, what I might do instead is get that in the right space first. If I do many more of these instances where I have to do extern to keep the OpenGL stuff outside of headers, then I might just dedicate a header to OpenGL specific data that needs to be passed around. Oh, that doesn't need to be. Wait, that does, but what's the complaint? The storage class may not be specified here. Did I not make this? Oh, so current slider texture, is that a member of? It is. It's a member of graphics already. Oh, that's not an OpenGL thing. Okay, that's why. So actually, I don't need to do an extern on that. That can actually just be left out. And I can reference it by including the graphics header. Include enterprise graphics. Getting really close to getting the texture atlas made and displayed. All right, head back down to the bottom. So this will be graphics. Oops. Current slider texture. Right, current slider texture. Member is inaccessible. Oh, because I need to make it. Hang on a moment. Load font file here I have not put into the graphics API yet. So let's go to graphics.h. Uh-oh. Oh no, it crashed. Visual Studio crashed on me. Oh my gosh, how did that happen? Editor program. Yes, please recover selected files. Thank you, Microsoft. All right. So where were we? Should be back to where we were. Let me go back to the code down below. Yeah, we were in the middle of setting these guys up. And we got the okay, so okay, that's great. I'm gonna have to do a little bit of stuff I already did. These were already marked as extern. These did not get changed. So okay, so I need what did I need? I need to redo some of my work now. Current slider texture handled by path of texture handle. So these two need to be exposed. And current slider texture needs to be made available through the graphics. Actually, I don't need to do graphics from here because this is going to be a member function eventually anyway. I do need to go back up here and say these guys are available by extern. Extern. Probably put them up here though. Yeah, you know what? I'll put them in the enterprise namespace, and that'll allow me to save a little bit of typing. And then include enterprise graphics dot graphics.h. And then I need to go into this header and actually make the load font file call a proper graphics API call. So I'll put that in. I'll put that in next to the texture stuff. Texture or load texture. This guy. Down here, I'll put it below all the texture loading stuff. So we'll do static texture handle. And then what did this take? I think it took a const SD string reference for the path, and I think that was it. If we head back to fontatlas.cpp, yeah, okay. And I'll worry about documenting it later. Okay. So I think we're looking good. These two are now available to externally link. This one was already available to externally link because it's actually a member of the header. It's a generic. I have access to it now down here. I just need to move these into this spot. And then, is that it? I think that's it. I think I'm done. So at present, this API will load up the font at whatever path I provide, generate its glyph shapes, or whatever it's called, the glyph, or the glyph geometry. I forget the name of the class. And then once it's loaded, perform some math to figure out the width and the height needed for a for the actual atlas if you're tightly packing these, and then provides that data to immediate atlas generator, which takes that data and actually generates the atlas in the bitmap constref, which will reference the atlas storage, and then I can just loop through that data. Oh, I missed a very important step. So I've generated the texture details that I need. I have not actually sent them to the GPU yet. It seems like it's always the big stuff I overlook. I go through all the nitty gritty quite well, but I don't think I actually called a method to send over the data. That would have been down here. Oh no, did I? I think I did copy GL text image into. Oh, okay. Never mind. So I did. So this is the part where we buffer it into OpenGL. Cool. All right. So let's see if I can use it now. How would I go about using it? Because at present, the 2D renderer API will load a texture using the texture API instead of using the font atlas. So I suppose I could just, for the purposes of today's demonstration, whip up a simple renderer that just does a quad from the font texture. Eventually I'll want that to be the same API, but I don't want to extend my ECS system just to test this. Let's do, well, first let's go into the state that I was testing this with. This guy. I should have a broken call now somewhere. Yeah, init. So enterprise load file is no longer enterprise load file. It should be graphics load file. And take a path for, let's pick a font. Oop. There's a bunch of randomly named fonts in here. Okay. I don't know what that's about. But let's do Arial bold. How about that? Isn't there a way to copy the path? Yeah, shift right click and then you can copy his path. And that will return a font handle now. So let me get one of those going. Texture handle or font text. Set it here in the initialization call. So now we've got an OpenGL texture handle for rendering from this font. Realizing right now that the string came back with backslashes instead of slashes because that's how Windows do. I need to get rid of that define, which I used to get the console application I was studying to get it a little bit more readable. Font text. And then I'll set up a simple renderer here. So let me go ahead and do a simple vertice. And we'll do 4. And we'll call it a sprite. And then we'll do EP position and EOP, negative 0.5, negative 0.5, 0.5. Okay, that's all good, but I'm gonna just make this 0 for the Z. And get rid of these. So now I've got 4 vertices that are located at 0.5 on each axis, going in the shape of a square. I need the indices now. 0, 1, 2, 2, 3, 0. Yeah, that's pretty standard fare. And then vertex array handle, I will need those. I don't need that anymore because I've got a texture handle already. And then I'll need a shader file. In this case, I'll do graphics shader file, content directory / I think the one I've been using was called material mockup. Yeah, material mockup.glsl. Good, and then this will use the same shader I was using for my batch renderer, but because of all the extra work I had done to set up includes and variant compilation in my GLSL files, this will compile a version that both supports batch rendering and just regular direct rendering without batching. So this should work out of the box, but I haven't tested it yet, so we'll see. Good, we've got the font texture loaded. I need to create that vertex array. Create vertex array. In this case, we've got 4 vertices with 6 indices for a square. Size of simple vert. Since I last used this code, I've now standardized the position input using the enterprise.glsl header. This one. So now EP position is the standard that I use for everywhere. And then, yeah, UV is still coming in as in UV. And then we do EP position, EP position for the offset. And now we're calling this one sprite, I think. Cube indices is good. And then we're using false for dynamic vertices and dynamic indices. We'll use false for both because it's just a static sprite. Yeah, all this extra code that I'm writing right now is just is just because I don't want to extend my renderer just to test the texture, because that API doesn't support my new API yet. So I'm quickly doing all the rendering code here. So each draw we will we do the clear, we do the depth test, we will do bind shader, KU. We're loading up, what was it called? Test renderer 2D is the shader. We're binding the font text. We're binding it to just text, I believe. And there's a little bit of ambiguity right now in here because some of the batch renderers shader code depends on materials, which I haven't implemented yet. So I'm just quickly double checking that it doesn't overwrite the name. So if we are not batching textures, so down here, it comes in as the name uniform sampler 2D name. The value passing doesn't happen, and texture just uses the name. Cool. So that should work just fine. Good. Yeah. This is some simple code for handling the first-person style movement of the camera. Bind shader. I guess I don't have to do the bind shader up here, or the bind texture. What I do need to do is I go to draw the scene, which presently is just the three different entities with sprites on them from my scene file. After I've drawn the scene, I'll draw the texture. So I'll graphics bind texture, and then graphics set model matrix to be GLM identity, so that it's in the middle. Oh, wait, that's not right. GLM, I have to do mat for still kind of getting used to GLM for my math library. I was using a custom one for a little bit while setting this stuff up. And then camera's already in the correct position. Bind texture set model matrix. And then I can just do graphics, draw triangles, and we'll do the font array handle. What did I call it? I think it was just VAH. Yeah. And then I will leave the others blank because we're just doing the entire array. Yeah, that sounds right. All right, let's see what I've screwed up. I haven't pressed F5 for a while because I was doing so much code writing that needed to be finished before I could even try compiling. So I'm sure that something's going to break. Just occurred to me, though, that if this does work, I'm going to have some Z fighting because there's a sprite already located at the origin. I could probably change that while it's compiling. Go to Enterprise, Sandbox, Content. Test 2D scene. Yeah, let me move the sprite from 0, 0, 0 to be like 0, 0, -5. So that'll be behind in a minute. All right, so let's see what I broke. Unsigned int VAH already defined in scene manager dev state.obj. Oh, really? Okay, where did I do that? VAH, got a multiple definition thing going. So I've declared at the top VAH equals graphics vertex array. So I've only declared it once in this file, but I must have non-static on both of this somewhere here and somewhere else. So I'll do static here and error list. Renderer 2D.obj. Yeah, so my very simple 2D renderer, I'm going to open that back up. Renderer 2D.cpp. Apparently I've got direct. Yeah, I made a vertex array handle in the global scope here. That's not static. So shame on me. Error list, unresolved external symbol, class map std. Okay, so this is referring to the externs that I was using in the font atlas at the top. And those are the only remaining problems. So I was referring to sampler type needed for texture as an extern. Oh, but yeah, these need to be outside of the enterprise scope. Because in the place where I define them in textures.cpp, they are not in the enterprise scope. So so I could have just done : : in front of the name, I guess, but I find it a little more elegant if I keep it in the scope that it's going to actually exist in. So we'll do the enterprise prefix for the types. Hopefully that'll be it. Okay, got a problem. Bind texture, slow assert, texture reference count, path of texture handle, at texture. So in the call stack, this is occurring. So I've already drawn the scene. I just don't see it yet because I haven't flushed buffers yet. The font texture is a 0. So the texture that I'm trying to bind, its handle, I think, is invalid. Because did I get any messages? I didn't get any error messages from my load font file code, but I had thought that, oh no, sorry, texture handles do not have a null version. 0 is a valid texture. So yeah, that should be 0, okay, because it's the first texture I load. Let's go back into the scope where there's a problem. Okay, so we had just called bind, texture is 0. Uniform is, let me unhash that. Uniform is TEX, which is good. And index is 0 because this is not an array. This is just a single sampler 2D. Path of texture handle at 0 is 0. So path of texture handle is not being updated correctly. And then when I go to look it up, texture reference count for 0 is 0. So there's no reference being generated. So I think I've forgotten a few things in my renderer, or my font atlas generation code. So first is path of texture handle. Should be set to the hash name of the path that I put in. So let me set a breakpoint there and try this again. Okay, so this line does get invoked. Path of texture handle. In this case, the texture handle is 4. That doesn't seem right, does it? So we start out at 0. We geogen texture it. And bind and all of that. But it's not the first generated texture. So why is its handle 4? So taking a look at the code, we got the init call, load context file, and so this is the input stuff. I load the shader file, and oh no, I do load the entities first. So the entities textures, the 3 sprites, the Hollow Knight, the Celeste, and the Zelda sprite, those sprites should have IDs 0, 0, 1, and 2. Unless, I can't remember if 0 is nullable. I probably should know that. Probably should know whether 0 is a null texture. So it actually makes sense that this texture would be loaded up as a higher number. Oh, I know what I did. Oh my god, I'm such an idiot. I didn't return the texture handle. I just returned returned the null texture. Okay, stop it. This needs to actually be return texture, which will be what I need. And actually, now that I'm looking at that GL uint texture, I need to move that to the outer scope. And for good measure, let me rename this to something a little more helpful, like return val. Yeah. Okay. And heading back to the bottom. Yeah, all right. Let's give it a shot. I think I might have left a breakpoint somewhere, but we'll see. Well, there's still an assertion. Okay, let's take a look. This time the texture coming in is 4. Path of texture handle at 4 is this value, which if I unhash it, comes out to C Windows fonts Arial BD.ttf, which is exactly correct. So we got the path texture reference count for this value. Is 0. I need to increase the texture reference count. I forgot to do that. Yeah, so texture reference count is global, I believe it's graphics texture reference count. I need to come down here when I've successfully set this up. Right? Or I need to do graphics texture reference count plus plus. Has no member texture reference count. Oh, is that true? Do I not? Oh, this was another thing that I needed to make extern. That I think I did do this before Visual Studio crashed on me, and it just didn't keep my work. So yeah, let me do that now. Yeah, and then down below, I can do texture reference count for return val. Actually, that's not right. Texture reference count is indexed by the hash name of the path. So I need to do path hash. Do I need to do a real path though? By default, when you provide a path to my APIs that use file stuff, they will use the enterprise virtual file system, which means that you start with the letter C to get to the content folder, the letter D to get to the data folder, and the letter S to get to your save data folder. I don't remember if I save as absolute or relative though. It looks like I do it as the relative path. Good. So head back down. So this would be hash name of path, which is provided as a parameter. Okay, cool. Let's see if this works. Come on. Okay, well, something's happened. Bind texture sampler uniform does not exist. And suddenly the other textures won't render, which is interesting. By default, if a shader doesn't work or load, it should be loading a magenta shader. That should be making the things pop out. For a split second there, though, we did see the other sprites. So there must be something about the new material system that I haven't tested. Let me take a look at the pre-processed shader code. I presently have it dumping out the shader code with all of the insertions and pragma options plugged in. So the variant of this we'd be using would be variant 1. So this is the first vertex variant of test renderer 2D. Yeah, we got the position and the per camera stuff, good. The batch texture stuff. This is not defined, so in this case, we would just be looking at this. This is the vertex. So we are looking at this. Meaning this line of code reduces to nothing. This line of code reduces to uniform sampler 2D text. In UV and out UV are the same. We multiply the position by the model view projection matrix. And all of that seems really basic. So it's probably not in the vertex shader. Let's take a look at the fragment shader. So we're not batching textures in this case, so all that code goes away. We have sampler uniform 2D for text, so that is what that looks like. IFDF, UP vertex. We are not in the vertex shader, so we are in the fragment shader. So now btext looks like this. And then yeah, so this is what the fragment shader reduces down to when you're not doing batching. So we got a uniform sampler 2D text, which does totally exist. Let's take a look at that error again. Sampler uniform does not exist. Program sampler 2D sampler text. It for sure does though. So I'm thinking that now that I'm looking at this, that this must be an error, not with my shader code or with my font atlas code, but probably an existing issue or pre-existing issue with my GLSL preprocessor. Or maybe the introspection phase where I actually get the names of stuff. Either way, let me do a search for that exact phrasing. I think it would be in here, in this file. Sampler uniform does not exist. And I'm just going to set a breakpoint for these errors. I'm thinking I might just want to do EP debug break in these cases, and then just like have it automatically break on the line if and when I encounter one of these problems, and just like add that to my source control. I'm going to need to think a little bit more deeply about how I handle these sorts of errors down the road, because I'm going to be overhauling the way that I do my warning and error reporting once I've got a debug console going. So yeah, there's only the 2 points in code that might have triggered that message. So let's put the debug breaks in there. We'll see where it breaks. Okay, so it broke here. We're in bind texture, graphics texture handle, hash name uniform, signed index. So we're looking in the sampler uniform types for the active shader name, active shader options, dot count. So the uniform is TEX, which is what I was looking for. The one that is definitely in the code. Active shader options is not empty, actually. That's interesting. Batch textures is enabled. Batch textures is enabled. So the way that I handle shader variants is that when you go to use a shader, you will toggle a keyword representing the variant that you want. So every time you want to make a variant in shader code, let's head to, this is an example. You would use pragma option and provide a list of keywords. The underscore represents a null keyword. So if you have pragma option underscore, then the if you have pragma option underscore, the underscore will be representative of not having a define. And then in the in each one of the keywords that you provide, a different version of the shader will be compiled where pragma option is followed by define and that keyword. So for some reason, batched textures is still enabled even though I've turned it off where I thought I had. So I'm calling the scene draw. Scene draw enables the shader option. With batch textures and true, meaning that whatever shader we had bound, we want to load up its variant where it's not enabled. Then at the end, we do disable shader option, which will take and toggle off the shader option before the next bind. I think I might be piecing together what's happening here. Bind texture, set model matrix, draw. Or no, I guess not. What I was thinking was that perhaps the issue is that I bind the shader, I draw the scene, that enables and disables the keyword, but then I never rebind the texture, but I do rebind the texture. Oh, sorry, that's rebinding the texture, not binding the shader. Okay, so I think what might be happening is that it's not actually changing over to the new shader option yet. Because I don't think I have that set up in the disable option API. So if that's the problem, then this should fix it. Ha ha! Okay, all right, cool. And there's link, which I moved up front to get out of the way. Okay. This represents a significant step in the work that I was trying to complete. Oh yeah, link's sprite ends here, so it actually is cutting off because I don't have, yeah. But all right, so let's take a look at what we got. This is the texture atlas for the ASCII characters in an MSDF format. Using the pre-calculated, like the default options for packing. So this texture is 256 by 256. It is pretty tightly packed. So what I can do then, when I go to render text, I render the glyphs using a special sampling method. I'm not like during this stream right now, I'm probably not going to even start with the whole arranging of text into kerning or whatever. But now that I've actually got the font being generated, and it seems to be, or the font atlas being generated, and it seems to be the right way up, I'm going to at least try my hand at a shader that uses it. So I'm going to see whether I can do the nice clean high res text rendering in this atlas. So you would look at it and see all the characters floating in space with crisp, clean, vectorized stuff. It might be a little bit easier for me to use my gamepad to control the camera here, because I'm going to be getting quite close and moving in variable speed amounts, which if I hold down the keyboard key, just goes at a fixed speed. Yeah, so let's give that a shot. Instead of writing a whole new shader, material mockup, instead of writing a whole new shader, I kind of want to do a header that implements the method. I'll do a whole new shader first, just for the sake of getting this going. So I'm going to base it off of my material mockup shader, and I'll do, in the content folder, I'll do a new file. We'll do font render test.glsl. And inside of that, we'll paste the code all over again. We'll support batching. And then in the place of, actually, let's not support batching right now. I'll deal with that prospect later. Since it'll be a uniform sampler to the text. The VTX pass doesn't apply anymore. Oops, shoot. That's still good, and VTX is now going to be just a texture. So now this is where I need to change things up a little bit. So first, let me at least make sure that this shader runs. If we go to yeah, so I need to actually do a separate load up here. So instead of just doing the material mockup, we'll also need to do the test font. Wait, what was it called? Font render test.glsl. And then when I go to bind the texture for rendering the font texture, or bind the shader for it, I mean, I would use, I need to give it a name. Font render test. I would use, oops, this keyword. Okay. Control S and 5. Just to make sure that the thing works. Good. So yeah, it's loading now with the shader I just wrote. Now let's hop onto the MSDF gen and take a look at its sample GLSL code. So they in the README for the MSDF gen that just handles the texture lookup by itself, the texture generation for individual characters instead of the whole sheet. We've got some code that is designed to help parse out the MSDF data. So I'll start with it. For starters, it's in UV. It's called text chord. So I'm going to go ahead and just take that out and replace it with the one that I have already set for the shader. Final color is my name for the out color that they've got going on here, so I'll replace that. And then sampler 2D, that's already taken care of here in the form of text. So I'll replace that. Vec4 BG color and foreground color. That's interesting. So there's a couple of new uniforms here, background color and foreground color. That's used in the algorithm, and I don't understand what they do. So let's take a look a little closely. MSD is the multi-sign distance. We sample the RGB points for the texture. Signed distance, it means that we're taking and consolidating, we're handling the data presented by the multi-channel, and we're producing the true signed distance to the shape by using the median value. Basically, there's inside of the signed distance field, you got the multiple colors. Each channel kind of spills out in a different way. So we need to find the median one, I guess, is how we identify the correct channel to deal with. And that's done with this helper function here. Screen px distance is screen px range. I don't recognize this. Is this a GLSL function? Here, screen px range represents the distance field range and output screen pixels. For example, if the pixel range was set to 2 when creating a 32 by 32 distance field, it is used to draw a quad that is 72 by 72 pixels on the screen. It should return 4.5 because 72 divided by 32 is 4.5. So this makes sense for being a fixed value in the case that we are doing just straight to the screen writing, because that's always going to be a uniform number of pixels on the screen if you're working in screen space. I am not. I'm working in 3D space. So you may want to implement this function using fragment derivatives in the following way, which is just pre-computing unit range as a uniform variable instead of px range for better performance. Let me go ahead and copy that code. Px range is actually fixed in my case. It's always 2. So I'll just do 2.0. Screen pixel range, unit range, back 2.0. Texture self, MSDF, texture size, MSDF. But instead of MSDF, we call this text now. And I'm assuming texture size is a GLSL function. I'm still very new to graphics programming, so retrieves the dimensions of a level of a texture. Yeah, I'm still kind of new to GLSL, so even though I've done a whole bunch of stuff with GLSL preprocessing and I know how the syntax works, I don't know all the function names and best practices for them. Text, yeah. Screen text size equals 1 divided by f width of text chord. Now with f width we have a problem because f width is available in 4.5 only. And strictly speaking, I can only work in OpenGL 4.1 and earlier because Mac OS doesn't support higher than 4.1. In my case, I think I can just leave it because my computer already handles higher higher OpenGL. But I'm not 100% sure because it could be the case that GLAD enforces 4.1 because I specified 4.1 when I generated my OpenGL binding library. So I don't know. We'll see. We'll try it, see how it goes. Just need to remember that I can't use that in the algorithm. I use for the platform generic. 0.5 times the dot product max. That's probably it. It kind of seems like it's all set up. I say with a question mark because I don't fully understand the algorithm. Went ahead and saved the shader, press F5, and we got a problem. What was the problem? So probably a compilation problem. Fragment shader compilation failure, undefined variable text chord. Oh, yeah, I didn't rename one of the variables. That's now UV. Good. And then back to Visual Studio, stop and start over. Okay, let's take a look. Compile shader source. Shader program contains non-sampler uniform. Uniform is EP per draw? That doesn't make sense. EP per draw is a uniform buffer, not a uniform. So EP per draw contains the position, EP position input. So that probably explains why I don't see the atlas in the middle of the screen anymore. But this doesn't make a lot of sense. Let's take a look at the code. Well, I guess, what am I saying? It's probably in the output of this guy. GLSL dump for font renderer. And we'll go to the vertex shader. So EP per draw is a uniform buffer. But when GLSL saw this code, or OpenGL saw this code, it thought that EP per draw was a non-sampler uniform. Actually, what am I saying? EP position is not part of a uniform buffer. That's a vertex attribute. So, what? What is this? You're so close. I've already gotten my goal for the stream done in the fact that I am generating successfully the MSDF, but I do want to try and wrap up the stream with rendering some clean text under my belt. So I do kind of need to figure this out. The EP per draw, why would it think that? Why would it think that it's a non-sampler uniform? I'm going to go back and find the place in my code where I make that error message, and I will search it. Shader program contains non-sampler uniform, and I will set a breakpoint and see what happens. Shaders.cbp contains a non-sampler. No. So that would have been in. Well, surely it was in here. Well, I thought that error would have been invoked by the shader source compilation, but yeah, graphics, compile shader source, shader program contains a non-sampler uniform. So it must be in this file. Because this is the compile shader source method. Let me search the entire project. The expression must be somewhere. For real though, it's taking this long to not find the phrase? Is there a typo in this? can't think of anywhere else where it would obviously be. We have to search for all warnings, including the phrase compile shader source. There's the warning. What? What? It was there in the file. I didn't see it? Okay, whatever. Shader program contains a non-sampler uniform. So this probably is the only place in code where that would trigger. And I was right. All right, so what do we got? The condition that failed was OGL uniform types at I is greater than sampler 1D and less than sampler 2D shadow, because I know sampler 2D is adjacent to sampler 1D. The index that we're looking at is 0. We haven't already generated warnings, and we are compiling. Which shader are we on? Yeah, we're in font renderer test, so we're doing font renderer test. We've got the EP per draw. Program, count, list indices. OGL uniform block indices is at -1. How's that? Oh, no, that's correct. It should be not part of a block. However, uniform types, let's take a look at it. Uniform types only has one value. It is 35666, which is, I have to convert that to hex. 8B52. Float vec4. It thinks it's a float vec4. That makes sense. OGL string out buffer. Maybe the I am not seeing what's going on. Because there's nothing in here. There's nothing in here that would resemble a vec4 uniform. Is there? Oh my gosh, yeah, there's two. I forgot about them. All right, so hang on a moment. So there's a bug in my error reporting then. So there actually are two uniform vec4s that found their way into the fragment shader that I forgot about. I didn't actually isolate what they were supposed to be set to and replace them with something that's not a uniform. But I should have been seeing BG color or FG color as the stuff in the uniform buffer. So let me quickly take a look at that. So its outstring buffer was set not part of a block. Oh, I'm a dingus. So I actually set the uniform name buffer within the first condition and tried to use it in the second condition. So it was using the last thing that was stored in the string out buffer. Okay, so that should be there. String buffer. And then we would correctly hash the uniform name there and use it in error reporting correctly there. All right, so I still have to fix the problem, but just to quickly confirm that I fixed the error reporting bug, I should see the correct incorrect uniform sampler name in the console this time. Shader program contains, there we go, uniform BG color and FG color. Okay, if the error reporting was correct, I would have immediately known what I did wrong. So let me fix that. Heading back to the MSDF gen algorithm. What is BG color supposed to be? I guess that's just the once you've got the thing rendered correctly, what the background and foreground color are supposed to be. Opacity has to do with the value that you got out of the other. So actually, I can just discard those uniforms and not use them. And I can use a mix. What is mixed? How does mix work again? I think it's just like blending those two colors together, right? Oops. I had the cheat sheet open for a little bit, but I forgot. Linearly interpolate between two values. Takes a gen type and an alpha. Specify the value to interpolate. Yeah, so we're interpolating by the opacity value. So instead of doing that, I can just do final color equals, make it white, and then have the opacity color be the alpha. So that'd be vec for 1.0, 1.0, 1.0, opacity. Cool. And if we were to run that now, ha ha! Oh, that is so cool. Would you look at that? Okay, so let's take a look at what we got going here. We had really crisp letters now, with a couple of issues maybe with the umlauts up here. You see they're a little blue next to the umlauts. But for the most part, very crisp, clean letters, especially the plain English letters. They are looking mighty fine, and they are doing so from a really low resolution texture. So yeah, now that I've got a sample going, where I'm generating the texture atlas, and I am able to see how a rendered output would look like. Let me go back to my gamepad because it'll let me do much finer speed adjustments. I can get an eye for whether I want to change how we generate the field. There's a couple of things I'm noticing right away. So like right in the middle of these curves, they actually appear to be discrete line segments. I suspect that that's probably due to the resolution of the atlas. It is also possible that they are being generated with different colors. I am on the fence about that. I'm still kind of new to this method of rendering, so I'm not privy to all the details, but like some of the curves look great. Actually, you know what? I think it might just be a resolution thing. Because like if you take a look at the outside of this queue, the curve over here where it's a lot more slight seems quite crisp. But there's actually a couple of tiny little spots as you get towards the edge where it starts to, or towards the top, where it starts to show like there's a discrete line segment there and there. I'm thinking that this might just be a thing where I might want to up the resolution a little bit. I'll have to think about that. I am also slightly wondering about the edges here. Strictly speaking, those shouldn't be a problem when I'm actually sampling the textures using the UV coordinates, because those are exactly on the edge. So when I'm actually using the atlas data to stitch together the strings, it shouldn't include that edge pixel, but I'm not sure either. So there might be a few adjustments I need to make to the way that I'm using the API to generate these atlases. But you know, considering how I didn't have a manual to use the API to generate the atlas, and I had to kind of like, not exactly reverse engineer it, but like research, like see a working example in a rather complicated C++ program to figure out how it works. I'm actually quite happy with what I've accomplished here. So now I've got the ability to get the glyphs and put them in MSDF format such that I can use a fragment shader to turn them into crisp, clean letters for the most part, with a couple of exceptions that I am going to stress out about, like that little corner there on the end. But yeah, I'll go ahead and call it a wrap on this stream, and not sure when I'll be back, but when I do get back, I will be looking at doing the actual process of stitching together sentences with this text instead of just displaying the atlas like I am now. All right, cool. Thanks for everybody who joined. Talk to you later.